Hello, everyone. You're looking at the second video lecture for the Research Skills ANOVA course. Good that you're still there in the second week. I hope you're all doing well and that you're more or less enjoying the course. As I said before, it's quite a hard course to take. Not very easy, it's not very straightforward, but I think it's very useful, especially in the context of your master's thesis. So I hope that you really get quite some knowledge and skills through this course that you can apply later when you're working on your master's thesis. So for today, let me share my screen again with you guys. There we go. Share. Right, and launch this. All right, so as I said, this is the second week of the course in the Analysis of Variance Research Skills course. And this is actually the second lecture. So I'm basically going to tell you in this video lecture what I typically also tell students at campus at university. So today, first, I'll tell you something more, a bit more about this first assignment, this analysis plan that counts for 15% of your final grade for this course. I'll provide a bit more information, and you'll also see that starting from Monday, April 13th, this assignment will be posted on Canvas. So you can find it there, and basically all the information that I'll be telling you will be also on Canvas, so you can read it there. Once that's done, then we'll talk about the content for today, and that's factor analysis of variance, so factorial ANOVAs, and also briefly we'll look at moderation analysis and what that means. And then usually in the second half of this class, there would be the practice assignment in class. Of course, this cannot happen this semester, but again, also this practice assignment will be on Canvas. And you can just work on it by yourself at home. And also the correct answers will be on Canvas. So you can check your answers with the correct answers to see whether you managed to do well or not. All right, so let's briefly firstly speak about this first assignment. So it's called assignment 1 because it counts for your final grade. And it's called the analysis plan. So basically what you will do is you will write an analysis plan 3 times for 3 different cases. And hand this in. So you'll be presented in text with 3 different cases, so 3 different case studies. And for each case, what you're going to do is that you're going to write a plan discussing exactly which analysis you would conduct, analyzing those data, and how you would do it. So for each case, you'll also receive a data set, so an SPSS data set. But what's important is that you'll get those data sets simply to look at them, and you don't have to actually carry out the analysis that you propose. So you get them just for information, but you don't actually have to carry out analysis. You just write down what you would do if you would analyze those data. There is a template that you can use, or actually that you should use for this assignment. So you can simply fill out the questions on this template form, and then you'll be fine. And as I said, the assignment will be available by now via Canvas. Yeah, so the deadline will be 2 weeks from the start of this assignment, so April 26th. But as I said before in the Q&A session, if there's some reason why you can't make this deadline because of the current circumstances, don't worry too much about it. So just email me and we'll find a flexible solution. If you just have time to work on things, then just work on this assignment and please hand it in before April 26th midnight. So then in any case, you'll still be following the regular schedule for this course. So you will still be well on track. And if you do that, then you'll get also my feedback on your assignment before May the 10th. So that's nice. So I hope. So if you have done everything correctly, you won't get much feedback, right? But that's maybe the best outcome. If not, then you'll get some feedback on things that you could improve. And that's nice because in a way you will use the first assignment as a basis for the second assignment. So then everyone's on the same page again. And also this assignment only counts for 15%. So my main aim is really to make sure you learn something about it. All right, some more instructions for this first assignment. So what you will do is you get this case study in text, so a text describing a certain case, and you also have the data set. What you will first do is deduce from this text, from the data set, one or more hypotheses and or research questions. And you will simply write those down. That's the first step. Then what you will do is mention a statistical test. So one of the tests that we have been discussing in this course, and you'll discuss which test you would use. So for instance, multiple regression analysis or factorial ANOVA. And then you will also explain why that test would be most appropriate for this research question or for those hypotheses. And then finally, you'll write a brief descriptive section for each case, in which you really go more into details, saying what you would actually do if you would carry out this analysis. So there would be, for instance, mentioning the dependent variable and the independent variables, how you include those in your analysis in SPSS, how you'll look at violations of your assumptions in SPSS, those kind of things. So all this is also specified on Canvas. So if you just follow the steps, then you'll be able to do this for each of those 3 cases. Yeah, so as I said, well, here's some good news. You'll get those data sets right, but you don't have to run the actual analysis for this first assignment. So you don't have to write down the statistical results. You also don't have to hand in the tables that you get from SPSS because you don't have to run the analysis yet. Or you also don't have to hand in any kind of syntax or output files. You just have to write down what you would do. That's the good news. On the other hand, those kind of things are going to happen for assignment 2, but let's not worry about that yet, and that will come later. Yeah, one other thing. So my advice would be to work on this over the coming 2 weeks. So during week 2 and week 3 of this course. And I would try, if I were you, I would try to work on the first 2 cases of assignment 1 during week 2, and then save the final case of assignment 1 for the 3rd week. Because especially for this 3rd case, this final case, you're also going to need some information that you will learn during the 3rd week. So I would first do the regular activities for each week, and then start during week 2 with the first 2 cases. And during week 3, I would do the 3rd case. And if you do it in that way, then you'll also be nicely ready in time before the deadline to hand it in. All right, that's what I wanted to say about assignment 1. All information is also on Canvas, so you can also read it there. And just start whenever you feel ready, whenever you've done the regular activities for this week, for week 2, including watching this lecture. Just also feel free to start with this assignment 1. All right, then today the topic is factorial analysis of variance, and also briefly moderation analysis. We're very much related to this. That's the topic for this week. You can also read about this, of course, in the book by Andy Field in chapters 12 and 14. And you can also, of course, if you need them, you can also watch his videos for more explanation to get a better understanding if you need it. Right, so let's first maybe do some recap of basic ANOVAs, so basic analysis of variance. You might have heard about this before already during a more basic statistics course. But basically what analysis of variance, what ANOVAs do, is very simple. So you use those types of analysis when you want to compare 2 or more groups, 2 or more group means. So those can be, for instance, old people versus young people, or you want to compare men to women, or you want to compare cats to dogs. If you want to compare 2 or more groups, then what you can do often is use an ANOVA. So what this ANOVA does, basically, it is a test for a difference between the groups. So say, for instance, you want to know whether men are more intelligent than women. Say you want to test this. Now what you can do, of course, is get a lot of participants, and you measure their intelligence, and you also ask them for their gender. And what you can do is compare the intelligence, the average intelligence of your male group to the average intelligence of your female group. And basically, you can do this using ANOVAs. So ANOVAs will test whether the group averages, so the group means, the mean score per group, is actually different from each other. What it doesn't do yet is tell exactly which group means differ from each other. So say you're comparing 4 different groups, then an ANOVA can tell you whether those groups differ from each other in general, but it won't tell you yet which of those exact groups will differ from each other. And later on, we'll look at some kind of test that you can do in addition to see which specific groups differ. All right, now one point that's quite important. So ANOVA actually does not literally compare the different averages. So it doesn't literally compare the different means. It's called analysis of variance and not analysis of means, because it actually compares the variance around the means in your different groups. So say you have a group of male participants, then they will of course vary quite a bit or a little bit around the average score within their group. And if you also have a group of female participants, they might also differ a bit within the group, or they might differ a lot within the group. And what ANOVA actually does is it looks at the variance in the different groups around the mean scores for each group. Now, this is all a bit conceptual and a bit technical, perhaps, but if you then find, if the ANOVA tells you that the variations or the variance within a group is smaller than the variance in the sample as a whole, so all your groups, all your participants together, then it concludes that your groups are different from each other. If there's no such difference between the variation within groups compared to the variation in general in all your participants, then there is no significant effect in your analysis. So this is all, this is quite conceptual, right? You can read more about this in the book, but let me also try to explain this to you a little bit better by using some illustrations so that you get a better grasp of what this actually means. All right, so let's look at some of those example data. So I just made this up, right? So I made up this graph that includes 15 participants. So say you have here 15 data points of 15 different participants. And all those small dots and triangles and squares, those are individual participants. And as you can already tell by the shape of their data points, you can actually place them in 3 different groups. So let's assume we here have a first group of 5 participants, and we have a second group of 5 participants, and we also have a third group of 5 participants. So we have those nicely, we have those 3 groups. And for each individual in each group, we have a certain score here on a scale of 0 till 8. And those scores are different. They can be different for different participants, right? So here, those 2 guys, they have the same score of 1, and this guy has a score of 2. This one here has a score of 3, etc. So all those different individual participants have a different score. What you now can also take, and what you can quite easily calculate, is the grand mean, so the grand average score for all the participants together. And in this case, if you add up all those scores, all 15 scores, and you divide them by 15, what you will get is a score that's more or less 3.5, right? And that's what we call the grand mean of all the participants together. Well, now let's say those 3 groups, you've asked all the people in those 3 groups, you've asked them whether, what their intention is to stop smoking. So let's assume that all those 15 participants are smokers, and you ask them you have asked each individual out of those 15, you have asked them, what's the chance that you think that you will stop smoking in the next 2 months on a scale of 0 till 10? Now, and then what this participant here has indicated is a score of 1. So not very likely that this person will stop smoking in the next 2 months. On the other hand, this person here has indicated a score of 7 on the scale of 10. So this person said it's relatively likely that in the next coming 2 months, I will stop smoking. So like this, for all those 15 people, you have different scores. On a scale here depicted till 8, but the actual scale might have been till 10. Then the other important thing here is that I said that there are those 3 groups, right? So let's say those 3 groups, this represents their socioeconomic status. So you have tested 5 people in group 1 with a relatively low socioeconomic status. You've also tested 5 people in group 2 who have a relatively average socioeconomic status. And you've also tested 5 people in group 3, and let's assume those people, those 5 people have a relatively high socioeconomic status. So now, of course, what you would like to know, are there any differences in terms of the mean scores in those 3 groups as a function of in which group they are? So are people with a low socioeconomic status less likely to say that they will stop smoking compared to, for instance, the other 2 groups? Right, so what you can already see on the basis of those data is that the different groups differ quite a bit, right? It looks like that people in those groups, on average, have a higher score than people in the other 2 groups, for instance. And this group is more or less in the middle, and group 1 has the lowest average score, probably. But of course, when you have those data, you can, of course, look at those, and you can say, well, it seems to me that those groups differ. But of course, it would be nice that you're sort of statistically sure that indeed those groups differ. Groups differ in terms of their scores on your dependent variable. Well, this is something, of course, SPSS can tell you. SPSS can simply tell you by performing what's called a one-way ANOVA, whether those groups indeed differ. So it looks like they differ, but you can't be really sure, right? So SPSS can tell you how sure you actually can be that those different groups differ. It's called a one-way ANOVA here. Sometimes people call this simple ANOVA because there's just one independent variable. So your independent variable here is socioeconomic status, either low or average or high. And in this case, you also have one dependent variable. Your dependent variable here is the score that you collected. How likely do people say that they're, what do people say in terms of how likely they find it to stop smoking in the next 2 months? So one independent variable, socioeconomic status, one dependent variable. So in those cases, you can do a simple one-way ANOVA. What you can also do, of course, is calculate the means for each group. So here, the horizontal red line is the average, so the mean for group 1. Here you have the mean for group 2, and here you have the mean for group 3. And now your question is, of course, do those different means, do those different groups differ from each other statistically? If you want to find this out, what SPSS is actually doing for you is calculating 3 different things. So here's the first thing. The first thing SPSS calculates is the so-called total sum of squares. So if you've been reading about regression last week, in the book you already came across this term. Let me explain it also to you here on the basis of this slide. First type of thing that SPS needs is this total sum of squares. Now, what is this? So if you here look at this graph again, you see again this grand mean. And what you also see is that your different observations are all in more or less different places compared to your grand mean. So what you could say is there is some variation between each individual score and the mean. So what you could do by hand, but what SPSS will actually do for you automatically, is calculate the difference between each individual data point and this grand mean. So say, if we look at this data point here, so this score is a score of 7, and let's say the grand mean is 3 and 3.5, so then actually the difference between the individual score and the grand mean is 3.5, right? So that's the variance between this individual score and the grand mean. And this is something you can do for each observation. So you will get a number for each difference between an observation and the grand mean. So for this score, for this score, for that score, for all those scores. If you then take the square of each individual difference, so here you would take the square of 3.5, then you get one square value, right? And you get this one square value for each difference between each observation and the grand mean. Now, if you take all those squares together, then you will get the total sum of squares. So for each individual observation, you get a square, you sum those, and this is your total sum of squares. What this actually means is this is all the variation there is in your dataset. So this is the first thing SPS needs, this total sum of squares. One bonus question for those of you who want to test whether they're really on top of things. A bonus question could be, why do you have to square those values? Why don't you just take 3.5 rather than the square of 3.5? So maybe think about this for 5 seconds. The reason why this is actually the case, why the square is taken, is that it's always nice in those cases to have a positive number. Otherwise, you might get positive numbers here, the square of 3.5, but negative numbers when the individual observation is smaller than the grand mean. Now, if this is a negative difference, if you square it, it becomes a positive number again, because the square of a negative number becomes positive, right? So -4 times -4 is not -16, but it's 16. I remember your high school mathematics teacher here. So that's why actually the sum of squares is taken and not just the sum of things. Otherwise, there would be values above the grand mean, values below the grand mean. Sometimes in certain cases, they might be even below 0, right? In different examples. That's why always the square is taken. As I said, that was just a bonus question for people who want to be really, really, really informed about everything. Right, so first type of information, total sum of squares. SPSS will need this and it will calculate it for you. You can also do it yourself by hand, but SPSS typically does this for you when you're carrying out an analysis of variance. The second thing that SPSS needs is the sum of squares between groups. And this is sometimes abbreviated by sum of squares B or sum of squares M. So B stands for between groups and M stands for model. This is sometimes referred to as the sum of squares of your model. This is slightly different than the total sum of squares. So in this case, in the case of the sum of squares between groups, what SPSS calculates is for each group, the average within the group. So here, this horizontal red line is the average for group 1. And now for each individual participant or each individual observation, it calculates the difference between the mean score of a group and the grand mean. So this is the same for all the observations, right? So for this observation, you get a certain score. For this observation, you get a certain score. For this one, for this one, for this one. And within a group, they're all the same. And again, for the same reasons as before, those are squared. Same for group 2. Here, the average in group 2 is closer to the grand mean. So those values, the difference between the grand mean and the group mean is much smaller, but again, it's 5 times, in this case, the same value, 5 times squared. Same for group 3. If you sum all those squares again together, so 15 different squared values, you will get the sum of squares between groups. This is the sum of squares of your model. That's the second thing that SPSS needs. Finally, SPSS needs one more thing, and that's basically how much noise there is in your data. And this is called the residual sum of squares within groups, or abbreviated as sum of squares R. And what this means is that for each group, still there's this average, right? So again, here, there's this horizontal red line for group 1. What you can also do is calculate the difference between each individual observation and the mean of your group. So here there's a value that will be squared again for the same reasons, another difference value, another difference, another difference, another difference. All those are squared for all 3 groups and then summed. And this is your residual sum of squares. So this is the third type of information that SPSS needs and that SPSS calculates when it is carrying out an analysis of variance. So those are the 3 things. Fortunately, SPSS is doing all this for you. So it's sort of nice to know what's going on. It's nice to know what the different labels in your output tables mean. But you don't have to do this yourself. Typically, you just let SPSS do this for you. And I hope that on the basis of those slides and on the basis of the book chapters, you more or less get an understanding of what's actually going on. But of course, for you, most importantly, will be things like those SPSS tables, the output that SPSS gives you to tell you whether there are some significant effects or not. Right, so this is a very typical ANOVA table here. So please have a brief look at this. And this corresponds to the example we've just been talking about. So the case where there was a dependent variable how likely do people estimate it that they will stop smoking in the next 2 months? So that's what you also see here. So the question here was, I plan to quit smoking in the next 2 months. On a scale of 0 to 10, what do people indicate? And then actually what you also see is those sum of squares here. Well, now basically what those three lines here refer to are those three things that SPSS calculates and that we just looked at. So the bottom line here is the total sum of squares. And basically that refers to all the variation there is in your data set. Then the top line is actually the degree or the amount of variance that your model, so sum of squares of your model, can explain. So out of those, the 667.904 variance that there is in total, your model, which in this case is your independent variable, right? Your one independent variable, socioeconomic status, explains this part of the variance, 117.896 out of the total variance. What this independent variable does not explain, that's your residual sum of squares. So that's here called within groups, right? So out of the 667, the residual, so the noise that's still there that hasn't been explained by your one independent variable is still about 489. So you have all the variance. Your one independent variable, in this case, explains a part of it, and there's still some noise left that's not explained by this socioeconomic status variable. So of course, this one variable won't explain the answers perfectly, right? It will only explain your independent variable, the answers on your question to some extent. But what's nice in this case is that this effect is actually significant. So what you can conclude on the basis of this table is that your between group independent variable, so socioeconomic status, significantly explains, the difference between your groups on the dependent variable. So people's intention to stop smoking in the next 2 months can be explained significantly by their socioeconomic status. That's what you can explain on the basis of this. That's what you can report on the basis of this table. And now you also know what those different sum of square measures mean, I hope. Right, so that's very nice that SPSS does this all for you. You don't have to manually calculate the sum of squares of your in total and of your residuals and so on. SPSS just does this for you, and you will find out whether the effect of your one independent variable actually is significant in explaining this variance. Right, so in this case, we spoke about 3 different groups, right? And what you found by doing this analysis is you found a significant effect. And this significant effect means that your different groups are actually differing from each other. But since we had 3 different groups, what we don't know yet is which of the groups actually differ from each other. So if you have 3 or more levels in your independent variable, so if you have 3 or more groups in this case, what you of course want to know is which groups actually differ from each other. Do they all differ from each other? Or does only group 1 differ from group 3, but does group 1 not differ from group 2? That's something we don't know yet on the basis of this ANOVA output table. And there are actually 2 different ways of finding out whether groups are different. And one is post hoc, so-called post hoc tests, and the other is so-called planned contrasts. This is only relevant when you have 3 or more levels. So if you have only 2 levels, say you're only comparing 2 groups, then already you will know that those 2 groups differ, right? Because that's the only comparison that there is. And if you look at your descriptive statistics, so the averages per condition, then you already know which group is higher, which group is lower. So you already know the direction of your effect. If you have more than 2 groups, so if you have, for instance, 3 groups, as we just had, you don't know yet which groups differ from each other on the basis of the output that we just saw. Okay, so as I said, in those cases, when you have 3 or more levels, there are 2 things that you can do. Either you do a post hoc test, and this basically means, you can do this in SPSS, this basically means is that all the groups will be compared to each other. So group 1 will be compared to group 2, and group 2 will be compared to group 3, and group 3 will be compared to group 1. So all possible combinations will be compared if you have 4 groups, all the 4 groups will be compared to each other. If you have 25 groups, all the 25 groups will be compared to each other. And this is more exploratory. So this you should do if you don't exactly have any strong expectations of which groups will differ from each other. If you have good theoretical reasons to want to compare all of them to each other individually. If you know beforehand that you're only interested, for instance, in comparing group 1 to group 2 and group 2 to group 3, but not necessarily, for instance, comparing group 1 to group 3, then what you can do is so-called planned contrasts. And in this case, you only compare a couple of different levels. So only the levels that you specify yourself. So there are not all the possible combinations being tested. There's just a subset of combinations being compared. And this is a little less exploratory and it's a bit more conservative because the more tests you do, the higher the chances are that one of your tests by accident will give you a significant result, even though actually in the population there wouldn't be such an effect. So typically the fewer tests you can do, the better. All right. So now you probably realized that this lecture was going to be about factorial ANOVAs, right? But so far we've only been talking about so-called one-way ANOVAs or simple ANOVAs. So what now is a factorial ANOVA? Well, a factorial ANOVA is very comparable to a one-way ANOVA. It's just the case that there's more than one independent variable. So in the example we just looked at, there was only one independent variable, right? And this independent variable was socioeconomic status. But in many cases, you will have more than one independent variable. So another name for an independent variable we saw last week is a predictor. But yet another name for an independent variable is a factor. And that's why if you have more than one independent variable, this is often called a factorial ANOVA. So before we just had one, so for instance, socioeconomic status, but in some cases, perhaps you have two. So you have on the one hand, socioeconomic status as your first independent variable, but you could also have, for instance, people's gender as a second independent variable. And if you want to have both those variables in your model as factors, so as independent variables, then you would typically do a factorial ANOVA. If you have two independent variables, one example of a factorial ANOVA is a so-called two-way ANOVA, because you have two independent variables. What this test does, the factorial ANOVA, it tests for those mean differences in each independent variable. So not just in the one or in the other, but in both of them, in the case of a two-way ANOVA. So it will look for mean differences in, for instance, socioeconomic status, but also mean differences in gender and influencing your dependent variable. Those are called main effects. So you could have a main effect of socioeconomic status, but you could also, on top of that, you could have a main effect of gender, for instance, another independent variable. What's now also possible is that there is a so-called interaction between your independent variables. So you can not just have main effects, so individual effects of individual factors, but it could also be the case that those different factors are sort of interacting with each other. And this is called moderation. That's also why moderation analysis is a very easy extension of factorial ANOVAs. I'll give you an example of this in a minute to illustrate this a bit more in detail. It's actually conceptually in your model and also in SPSS. What now happens if you have more than one independent variable is that SPSS is not just looking at your variation within groups and between groups for one independent variable, but for each independent variable. So for each independent variable, it will basically do the same thing as that we looked at before. All right, so that's the conceptual story about factorial ANOVAs. If you run such a factorial ANOVA, then you get a bit more complex output table. You get a lot of output tables, but here's one, the most important one. So now let's look at a different example in this case. And this example also relates to the practice assignment for this week, so it will come back there. So now let's assume that you again did a little study and you asked people, you had people look at the website and you asked people overall, how much did you like this website on a scale of 0 to 10? So here you see your dependent variable You could call this people's attitude towards the website. And here you see the question. Overall, how much did you like this website on a scale from 0 to 10, or on a scale from 1 to 10? So this is your dependent measure. And in this case, what you see here is that there's two independent variables. One is the interactivity of the website. So you've had people look at either an interactive website or a website that's not interactive at all. And then you ask them, overall, how much did you like the website? How much did one person like the interactive website? How much did another person like the not so interactive website? So interactivity is one independent variable. It's either very interactive or not interactive. This is one independent variable. If you would have had just this one independent variable, you could have done a simple one-way ANOVA. But in this case, you have two. So in this case, also age group here is one of your independent variables. So you have asked all sorts of people to look at different websites. And some of those people are a bit younger, other people are a bit older. And what you have done is that you've split your data into a young group of participants and an old group of participants to test whether age group, so people's age group, whether they're young or old, influences whether they like the website. So what you can find out in this little study is whether the interactivity of a website influences whether people like it, whether their age influences whether people like it. On top of that, you now also get the interaction effect. So is there an interaction between those two variables, between the interactivity of a website and the age group that the person that you're testing belongs to? Now what we see here is that here's a significant, here's a p-value of 0.56a. Of course, this p-value is not lower than 0.05, right? So there's no significant main effect of the interactivity of a website on whether people liked this website. So there's no main effect of interactivity. Similarly, you find no main effect of age group. So there was no difference between young and old people overall in how much they liked the website. Nevertheless, there is a significant interaction effect now. So this p-value 0.000 obviously is smaller than 0.05. So here you can report there was a significant interaction effect between interactivity of a website and age group on how much people liked a website. So that's what this table is basically telling you. So this interaction term here, this is also often called moderation. And we'll look into this also in a bit more detail to explain what now actually this interaction effect actually means, right? Before we do that, a short note about effect sizes. So last week, remember we also looked at effect sizes, but in those cases they were called R square. So this R square value last week told you how much variance, how large the effect was actually that you found in your data in the case of regression. Also in the case of ANOVAs, there are so-called effect sizes that you can use to look at how large your effect actually is. So an effect can be significant, but it can still be a relatively small effect. It can also be significant and be a relatively large effect. So that's something you can test and tell by using effect sizes again. Now, you could actually, on the basis of this table, calculate those effect sizes yourself. And the effect size that is mostly used in the case of ANOVAs is a so-called eta square value. And this is the sum of squares between your groups for a particular independent variable divided by the sum of squares total, so of all your observations together. But of course, what is nice is that you can also just ask SPSS to calculate this for you, and SPSS will do this without any problem. It will just give you an extra column in your output tables, giving you those eta square values. If you wanted to calculate this yourself for each independent variable, you could do it on the basis of this table as well. So you would take this case, if you want to calculate it for interactivity, you would take the sum of squares of this measure and divide it by the sum of squares in total. And then you would, what you would see here is that you would get a very, very small effect size. This makes sense, right? Because your effect was actually non-significant. So it's also not we don't expect there to be a large effect size for an effect that's actually not there, right? Same for age group. Again, there was no significant effect, and if you calculate the effect size, it's super, super small, so 0.00. If you would add some more zeros, in the end, you might get a 1 somewhere, but it's a very small effect size. Again, it makes sense because there's no significant effect, right? For the interaction effect, you could also do this, and then we did find a significant effect. And here, if you make the calculations, you will get a certain number. So here, the eta square value is 0.11. And what's important here is that this eta square value is always located again, like the r square value from last week, between 0 and 1. And actually, this is a rule of thumb that you can use to conclude whether you have a small effect or a medium effect or a large effect. If your effect is in between 0 and 0.09, then it's actually small. If it's 0.09 or higher up till 0.25, then you can call it a medium effect. So here we have a medium effect, or you could say a medium to large effect because it's actually in between 0.09 and 0.25. If it's 0.25 or higher, you can really speak of a large effect of your independent variable on your dependent variable. Or in this case, you speak about the medium to large interaction effect between those two factors. Also last week, we saw that there were several assumptions for regression analysis that you should meet, that your analysis should meet to interpret your findings reliably. In the case of ANOVAs, there are actually mainly 2 assumptions. So for regression last week, there were 4 or even 5 different assumptions. For ANOVA, there are just 2. One is the assumption of normality. So here it's important that the data that you have within your different groups is normally distributed. And this is what a normal distribution looks like. So if you would plot all the scores within a certain group in a graph, then your data should look more or less like this. So there should be some outliers on one end, some outliers on the other end, but actually most people are sort of in the middle. If that's the case, then your data are normally distributed. If that's the case within each of your groups, then you can reliably interpret your output data, your output tables that SPSS gives you. The other assumption here is that your variances should be homogeneous. So in your different groups, in the different levels of your independent variables, the variance should be more or less the same. So that, in other words, what this means is that in your different groups, there shouldn't be much more noise in one group than in another. So that's the second assumption. If you don't meet one of those 2 assumptions, then there are different things you can do. And in the book, in chapter 12 and in chapter 14, it's specified what you can do if you don't meet one of those 2 assumptions. Often they will be met, sometimes they won't be met, but your SPSS output can actually tell you whether those 2 assumptions are being met. For instance, in the so-called Levene's test. So this is a test, this is also an output table that SPSS will give you. And typically, if this effect, this Levene's test is not significant, then it means that you're safe. So then you can just interpret your data reliably. Similarly, you can check for the normality of your data by plotting your data for each group and just checking whether it's normally distributed or not. If it's not normally distributed, again, there are things you can do to make your data normally distributed, or you can look into different tests to use. All this, if you want to know more about it, it's very nicely explained in the book. Finally then, moderation analysis. So far we've really been talking about ANOVAs. Moderation analysis, in the case of simple moderation, looks like this. You have a certain relationship between 2 variables again, say variable x and variable y, but this relation between the 2 is moderated by some different variable. So if you think back of the example where that we just looked at, so for instance, again, you have an independent variable. Let's say the independent variable here is the interactivity of your website, of a website that people looked at. And what you might find is that the interactivity of your website actually explains whether people like the website. So imagine you have in this case found a significant effect of the interactivity of your website on whether people like this website. It could be the case that people like more interactive websites in general. Now, what's important to find out in some cases is whether this effect between those two variables is moderated by a different variable. In other words, whether this relationship interacts with a different variable. So in this case, this moderating variable could be age. It could be the case that more interactive websites are more interactive websites lead to people liking them more, but it could be the case that this is only the case for young people and not for old people. So then this relationship between X and Y, it would actually be there for young people, but it would not be there for old people. So actually what you could say then is that your age group moderates the relation between X and Y, between one independent variable and one dependent variable. And this is actually what we also saw in this interaction effect, right? This interaction effect that we just saw in this ANOVA table, it basically meant that in one of your age group, this effect between X and Y was there, but in your other age group, it isn't there actually. Probably in the young participants, the effect was there, but in the old participants, it was not there. So this is what an interaction effect in this case entails. There is basically a moderating variable, so in this case, age group, that moderates this effect that is there only in one group and not in the other. Right, so this is also referred to as an interaction effect or as a moderator. And now one question, of course, could be, one question that you could have could be, if ANOVAs give you this nice interaction effect, right? Why would there be also a separate moderation analysis in this process macro? So remember last week we briefly spoke about this process macro, so this extension to SPSS that you could download. In this extension, what you could also do is so-called specified moderation analysis, specifically to test for moderation. Why would you use this when you can also simply look at ANOVAs and interaction between independent variables in your ANOVAs? Well, the answer to this question is that this really depends on the nature of your moderating variable. So if your moderator is categorical, so remember from last week what a categorical variable is. If your moderator is categorical, then you could look at interaction effects in the case of ANOVA. But if your moderator is a continuous variable, then you would actually use this process macro and do a dedicated moderation analysis there. So it really depends on the nature of your moderating independent variable. So in the example we just discussed, we looked at different age groups. So their age group was actually categorical. The people in your sample would either be young or they would be old. So it would be one or the other. So this is categorical. However, you could, of course, also treat age as a continuous variable. So you wouldn't group people into two different groups. You would just take their age in general, which could be anything between, say, 18 and 105, and you just use it as a continuous variable without doing any further grouping. And if you use a variable in this way, then you would do moderation analysis in this process macro, because you're taking a continuous moderator, you're testing whether there's a continuous moderator moderating an effect that you're interested in. So that's the difference. In the second, in the practice assignment for the second week, for this week, you will play around with this again. So again, you will look at either a categorical or a continuous moderating variable. All right, so we're almost there. If you didn't install this process macro yet last week, please do it this week. So again, in the chapter about mediation and moderation in Andy Field's book, this chapter also tells you that you should do this, and it also refers back to an earlier chapter where it's specifically explained how to do this. And then using SPSS, you will can get this add-on to your for free to your SPSS program. And then in the end, moderation analysis will look something like this. But again, what my suggestion would be is that if you have some extra time this week, feel free to play around with this. but focus mainly on factorial ANOVAs for this week and not so much on moderation analysis yet. All right, this is what I also typically tell students in the classroom on campus. And then typically now there would be a break, and then after the break there would be the practice assignment for week 2. Of course, again, we can't do this in class. So my suggestion would be, after having seen this lecture and after having read the chapters for this week, please just start with the in class or with the stay home assignment for this week. And just use it to test whether you really understood everything this week. And also the answers will be posted again on Canvas, so you can compare your answers to the correct answers that I've posted. And if they're very similar to the correct answers, then that's an indication that you're doing well, that you understood everything well. And if they're not so similar to the correct answers, then that might be a sign that you should maybe watch one of Andy Field's lectures, or read the book chapter again, just to get a bit of a better understanding of the materials. All right, then let's finish again with an overview for this week. So for week 2, this is the topic, as you know by now. We looked at this more in depth. Those are the readings for this week, chapters 12 and 14. If you're using an older version of Andy Field's book, then please look only at the titles and not at the numbers of those chapters. As I said, there are Andy Field's videos on YouTube. If you need some more support, if you find those things very hard to, if you find the chapters and also this online lecture hard to understand, then this might be a way out. So you might look at his videos for some more support to get a better understanding. Well, for this week, there's also obviously this lecture, which you watched again. Well done. Happy that you're still there in the second week of this course. And as I said, if you've done the readings and watched this lecture, you can now also start working on the in-class assignment. Also this week, there will be a Q&A session again. If you have any questions about last week or about this week, any question in general, feel free to join, and I'll be there to answer your questions. In my weekly Monday morning email, I'll also announce when this will take place, but in general, it always takes place during the scheduled lecture hours, which are which should be in your timetable, in your Tilburg University timetable. So we'll just stick to that, just to be sure that that this is a moment that everybody should be able to make it if you have questions, because that's the time slot that has been kept available for this course specifically. All right, then that's it for this week. I'll stop sharing my screen again and try to get rid of my face. Hope you enjoyed it again today. And I hope to see you next week again, or this week during the Q&A session.